purification. Sticking on the theme of water purification, today we're going to be able to make one of these from all of this. So like I mentioned, we're going to be able to build a kettle from all of this. And what we're going to build today is called a solar kettle. And we're going to harness the power of the sun and the sun's energy, turning the sun's energy from light into heat, and then we're going to use it to heat up this bottle of water. So we have to think about several things before we start doing this. We need to think what absorbs and reflects the sunlight to be able to maximize the amount of heat that's going to go into my water. To start, I'm going to choose black paint, and I'm going to spray paint my bottle black, because I know that black paint absorbs light, and which then turns into heat. You can change, I'm using spray paint, you can use any paint you want, it doesn't matter. You could even try wrapping colored paper around the bottle and see if that works. Or you could try to use different colored paints and see if they make a difference to the amount of heat that is in my water. So I'm going to spray paint my bottle now. With my bottle of water drying over here, that is now being spray painted black to hopefully absorb all that light energy and turn it into heat energy, I'm going to start making the rest of the solar kettle. We need a small bottle of water, a medium-sized bottle of water, and a big-sized bottle of water. Now, the important thing are these bottles are see-through. They don't, if you haven't got access to one of these, don't worry. It's 3 different bottles as long as they can fit inside each other. And they are see-through. What type of bottles? It doesn't make any difference. Okay, so the first thing I'm going to do is cut off the end of my middle bottle of water. If you're not confident in doing this, please ask an adult for guidance and help with doing this part. And this is going to now stand over the top, it fits. The next part I'm going to do is to be able to use this big bottle of water, and I'm going to cut the end of this bit. So the idea is that this and this allow sunlight to travel through, but the air inside it acts like an insulator, and it will keep the heat inside, heating my water bottle up. Other equipment that I have is a bit of garden hose. Now this is optional. I'm going to use this because I'm going to feed it in, and I'm going to use a thermometer to check the starting temperature and then the end temperature of my water to be able to see how effective my solar kettle really is. Another part of my solar kettle that I'm going to use is simple tin foil. I know the tin foil is, as we can see, very shiny, and it will reflect the sun's rays back into the bottle. So my idea is that if I cover half of the bottle with tin foil, the sun will travel through, hit the tin foil at the back, and shine back into my solar panel kettle. I've got a little bit of tape here. Just to take the foil in place. One side. Now using the other side. So as you can see, that on one side there is foil, and on the other side, I'll take the label off so you can see clearly, on one side we have foil and on the other side is not. And I'm going to make sure that this way faces the sun. So we're talking about several scientific principles here to be able to make sure that I can get my solar kettle. The first principle we discussed was the color black. And the color black absorbs a lot of light. And then as it absorbs light, that light is transferred to heat and will heat up the water inside. But that's not enough to be able to make it into a kettle. The next idea was that we put another bottle over the top, and that will trap air in between the two bottles, and that will act as an insulator. And the third idea is that we use the silver foil as a reflection tool to reflect the heat back into my solar kettle. So all that's left to do now is to test it. So first thing to do is to test the temperature at the start of the experiment. And I'm going to test this water temperature using a thermometer, dip it inside, take a reading. And this water is quite warm. It's 29 degrees, about what temperature it is outside at the moment. So it starts off at 29 degrees. I'm going to take this out. I'm going to feed this in just so it's easy for me to be able to test the water temperature by using there we go. And finally my big one over the top. And there we have it. Now I can tie a little bit of string onto the end, leave this into the sun, let it heat up, tie a little bit of string on, feed my thermometer back down my hose pipe, and test the water temperature every half an hour, every hour. That's up to you guys. So it's time for you to have a go yourselves at creating your own solar kettle. Don't forget those 3 scientific principles we talked about: color and how heat is absorbed through color, the air insulation that we have within our solar kettle, and the reflective material that we used. Maybe you could change the color, the reflective material, how many bottles, how much air insulation you use. How you design your solar kettle is completely up to you. Your challenge this week is to be able to get the hottest water by purely harnessing the energy from the sun. Now, I must have a health and safety warning, guys. We do live in Dubai and it gets very, very hot here, okay? The water inside will get very, very hot. Be careful when pouring out and testing the temperature of this water. This was another purification water technique that we use within the natural environment using recycled material. Hope you enjoyed, and I can't wait to see your solar kettles. Thanks very much.